So for today, we are going back to trigonometry. And so I just want to do a little bit of a recap to start. Traditionally, students have to know about what the trig ratios are. So we have the sine ratio over h, we have the cos ratio a over h, and we have the tan ratio over a up here. Now in grade 10, we just stay with a right angle triangle, but in grade 11, we extend the angle past 90 degrees. So say, for example, I tell you something like the sine of 210. It's hard to imagine an angle being 210, or it can't be possible in a normal triangle. The way we get around this is we think of the angles being on a Cartesian plane, and we think of each axis being like this. And so the sine of 210 is actually forms a triangle in quadrant number 3, where the angle of 210 would be. Give me a thumbs up if that looks familiar to you, the idea of extending angles past 90 and using what's called the cast diagram or the Cartesian plane. Because that's just some basic fundamentals for today. And then if we take this idea a little bit further, we can summarize the behavior of the trig functions using the acronym CAST. And what we say is cos is always positive in quadrant 4. Everything is positive in quadrant 1. S is positive, or sine is positive in quadrant 2, and tan is positive in quadrant 3. Now, if these are the ones that are positive, then the other ratios are negative. So, for example, if I said to you, the cos of 150, is that positive or is that negative? Tell me in the chat. If you use the cast diagram, is it positive or negative? So the cos of 150, well, 150 would be over here. And if we were forming a triangle, it would look like this. But the main thing is you're in the second quadrant, and so cos should be negative. Now, something else that we like to do is we use these things called reduction formula. So if you look at something in quadrant 2, you can always write it in the form 180 minus theta. If something is in quadrant 3, you can always write it as 180 plus theta. If it's in quadrant 1, you can write it as this. And if it's in quadrant 4, you can write it as 360 minus theta. And all this is doing is it's rewriting the angle in terms of its distance to the nearest horizontal. Now, that sounds a bit weird, but what are the horizontals? There's a horizontal over here, and that would be the 180 or the 360 degree horizontal. So let's just show you how this would work with this one. You've told me already that cos of 150 is negative, but maybe before I do that, I want to write this as the cos of 180 minus 30. Is the cos of 180 minus 30 the same as the cos of 150? Yes, it is. And all I need to do to reduce this is I know it ends up negative, and then I say to myself, well, how far away is this from the nearest horizontal? And it's just going to be the value that's here. And so we can say that the cos of 150 is the same as minus cos 30. And that's called reducing a trig ratio using a reduction formula off the horizontal. Now, I'm not sure if that was super clear, so let's try another one. If I said to you, I have the sine of 210, and I want to figure out if it's positive or negative, and I want to reduce it. Could you do that for me? Tell me in the chat what you would get if you reduce the sine of 210 using the reduction formula that you can see in front of you and that you've probably learned previously. And let's just check everyone is on the same page. So I'm going to rewrite it in terms of the nearest horizontal. And then I ask myself, after that step, I need to now ask myself, is it positive or is it negative in the quadrant that it's in? So it's going to be quadrant 3, so sign is negative. And then because I'm using reduction formula, I can just write this as minus sine 30. Okay, so this is a very common thing that we have to reduce angles that are greater than 90 to acute angles. And the most common way of doing this is using the horizontal. You can use the vertical, and then we use what's called the co-ratio, which I'll show you a little bit later. But for now, let's just stay with this. And I think the basic idea is familiar to most students. Okay, so here it says here, any angle, obtuse or reflex, can be reduced to an acute angle by using the following: negative angles to positive, reduce angles greater than 360, use reduction formula, which we were just doing right now, and use co-functions. What if I said to you, what is the sine of 420? What would you then do to reduce that? This is like the case when you're reducing angles greater than 360. What's the nearest horizontal to 420? If you think about the cast diagram, you have 0, 180, and then this is 360. And if you were visualizing this 420, you get here and you keep going. What's the nearest horizontal? I think the nearest horizontal is 360. And so you would rewrite this as that. What is that going to reduce to? So you know it's 360 plus 60. What quadrant have you ended up in? And what's the sine of 420 going to reduce to? Well, it's in quadrant number 1, so it has to be positive. And then all you do is you exclude the horizontal and you just go straight with that. And you get that one over there. Okay, so so far we've done using the reduction formula. We've done reducing angles greater than 360. What if I want to reduce a negative angle? So say, for example, I give you the sine of minus 30. Okay. What is that going to reduce to? What quadrant is it in? What's the nearest horizontal to minus 30? How are we going to do that? Which quadrant would I be in if I want to create a negative angle to a positive? So minus 30 would be going in this direction. Yep. So you could add 360 is the one way you could do it. Yep. So what Andile is saying is actually I can just add 360 and make it positive. That's one way of doing it. Or you could also just say 0 minus 30, because 0 is also horizontal. That will both work. And the most important thing is that it's not going to be in the first quadrant. It's actually going to be in the fourth quadrant. You can kind of see it with what Andile is saying. Andile is saying, look, minus 30, if you add 360 to it, that's the same as the sine of 330, which is like going the other way around. So you're going to end up in quadrant 4. Now, if sine is in quadrant 4, is it going to be positive or negative? Okay, so it's going to be minus, and then we'd say minus sine 30. So you can see here, I use 0 as an horizontal, so I could just get the 30 like that. Or if I have the sine of 330, I can then rewrite it as sine of 360 minus 30. And then you can see that it's going to be minus sine 30. So both ways would give you the same answer. So that's what we call reducing a negative angle. And so we can do one more, because I'm not sure everyone's perfect with that. If I say to you, what is the tan, or actually, no, let's go with the cos. What is the cos of minus 60 going to reduce to? So ask yourself, what quadrant are you in? And so it's going to be positive, and then we get positive cos 60. And I just used the 0 because 0 is the nearest horizontal. Okay, so we have done, I know I'm doing quite a few of these things. Let me, so what have I done? I've done reduction, I've done this, I've done that. Then I do want to squeeze in some co-ratios as well, just to make sure that you understand that, and then we can get properly crack-a-lacking. Give me a thumbs up if you followed everything I've done so far. Give me a thumbs down if you are feeling a bit lost. Okay, so what do I mean by co-functions? So sometimes you may want to reduce something to the nearest vertical and change the ratio from a sine to a cos. So the way this works is that instead of rewriting it in terms of the nearest horizontal, you write it in terms of the nearest vertical. What is the nearest vertical line to 110 degrees? What's the nearest vertical line to 110 degrees? It's going to be 90. Okay, so using the logic so far, we can say that this is 90 plus 20. Okay, but here's the different thing. We do say to ourselves, what in this quadrant that I'm in? So is sine positive or negative in this quadrant? Is sine positive or negative in this quadrant? Okay, it's going to be positive. But here is the sneaky thing. If you are reducing something off the vertical, you can't write the sine of 20. Even though you can see that 20 sitting there so deliciously, you have to use the co-ratio of sine, which is cosine or cos. And so we can say that the sine of 110 is positive cos 20. And you can check this on your calculator, but it's important that you have the flexibility to reduce something off the vertical if you need to. And then you have to do a slightly different way of doing it. So I want to test you with something else. I'm going to say, can you reduce the cos of 250 using the co-functions or the co-ratios? It's this one over here. See if you can do it by yourself. What does the cos of 250 reduce to if you are using the nearest vertical axis? So I think the nearest one is 270. So I'm going to rewrite it as the cos of 250 plus 20, sorry, not 250 plus 20, the cos of, wait, my brain had a moment, 270 minus 20. So 270 minus 20. Now, is cos positive or negative in this quadrant? What do you guys think? Is cos positive or is it negative in this quadrant? Because 250 doesn't get past this line. Is cos going to be positive or negative? It's going to be negative. Yes. So what we're going to say is that we can change it now. It'll become negative sine 20. So notice how the 20 is still there, but the ratio has changed because you are using cos. And what's the co-ratio of cos? It's sine. And in this quadrant, cos of 250 is negative. So it has to stay negative overall. Should we do one more of those? So would that be helpful? Give me a thumbs up if you followed this and you don't need another one. Give me a thumbs down if you would like another one. Okay. So let us do one more. If I say to you, what is the tan of 260? And you have to reduce it using the nearest vertical. Now remember, or the nearest cofunction. You only use cofunctions if you can't use horizontals. If they're harder to do than horizontals, but it's important to just at least know sort of how that works. So what is the tan of 260 going to reduce to? Let's try and visualize it. So I know I'm in this quadrant. So that's helpful. I know I'm going to write it as tan 270 minus 10. I then say, oh no cots here. Oh, you're right. Sorry. Guys, I shouldn't have actually included this because it's not actually, we're not covering cot in grade. It's not explicitly in the syllabus, but I will do it anyway. So if I go tan of 270 minus 10, it's going to be positive in that quadrant. Now, the co-ratio of tan is actually cot. Now, that is not actually examinable. So you won't ever get a question like this, but just anyway, it'll be plus cot of 10. But don't worry if you've never heard of cot before. It's not in the syllabus specifically in this context. But yeah. Don't worry. If you're stressing, don't stress. It's not going to come up. It was just, they're not going to ask you for the co-ratio of tan in this way. I just made that question up as I went. Okay, let's look at a past exam question that maybe brings in some of the stuff we've been learning about. Let me see if I can find one. Let's do this number one, and then I will come back and talk about other things. But have a go and see if you can simplify this one without using a calculator, and see what you can reduce by yourself. And then we'll talk about what they mean when they say without using a calculator. Go ahead and give that one a bash. You can do it. Let's see if the power's back on. If load shedding is still. Oh, I have power back. Oh, nice. Okay, so if we think of 180 plus x, it's going to be in that quadrant. So in that quadrant, we would say that sine of 180 plus x becomes minus sine x. So that is that one taken care of. If we talk about the cos of 330, I'm going to have to go all the way over here. And now I'm in quadrant 4 and I'm positive. Notice how I'm using the horizontal. So I don't need to change to a different trig ratio. It's going to be the same trig ratio. It's going to be cos, and it's going to be 30. Let me zoom in a little bit. Now, what about the tan of 150? What's that going to reduce to? Well, it's how far away is it from the near? Well, first of all, is it positive or negative? It's going to be negative. And because I'm using the horizontal, it's still going to be tan. And how far away is it from the nearest horizontal? It's just 30. I am skipping a step here because of it being all together, and then the sine of x is just going to stay the same. What is my next step going to be? Does anybody have an idea of what my next step would be? Because remember, I have to simplify this without a calculator. So I think sine x over sine x can cancel out. Yeah. And I also think a negative times a negative, so there's a negative here and a negative there, together those become a positive. So I'm left with, have a look here, I'm left with positive cos 30 times tan of 30. Now, at this point, there is an identity in trigonometry for representing tan. And the identity says that the tan of 30 can be written as the sine of 30 over the cos of 30. Now, what should I do next? So now I have to, this is like over 1. And so this would cancel. And we're left with the sine of 30. Let's go to Sate. Sate has a question. Sate, can you hear me? I've unmuted you, I think. Yeah.
Good evening, sir.
Hey, how can I help?
So when you were canceling out sine x, we were left
Yes.
with a negative, right?
I
So
wasn't. Oh, I was over here. Yes, that negative.
yes. So I wanted to ask how we were left out with the cos 30 degrees. Why
Okay.
is it a positive?
Okay, so there's a negative sitting in front of the tan 30. And if these two negatives interact, right, it ends up being a positive. So if you multiply two negatives together, you end up getting a positive. So that's where the positive comes from. Does that make sense?
Yes, sir. Thank you.
Perfect. Now, there's one more thing we have to evaluate. We have to evaluate the sine of 30 without using a calculator. What are we going to use to evaluate the sine of 30 if we don't have a calculator? Who has an idea? Special angles or special triangles? Yes. And so you need to know these. Let me see if I can remember mine. So the sine of 30, so that would be 1, and that would be root 3. So there are two triangles that you need to know. It's the 30, 60, 90, and then the 45, 45, 90. If you used just this triangle, what would the sine of 30 end up being? If you just used that triangle, what would you say the sine of 30 would be? So sine is O over H. So that would just be 1/2, which would be a half. So if you look at that, that would typically be a 5-mark question. And we had to use the reduction formula a couple of times. Okay, Clomela was asked, can we see the other special triangles? You can. I actually have one prepared here for you. So if you want to take a screenshot, you can do that. Let me just make it a bit bigger so you can all see. And let me move the other stuff out the way. So in the second half of the lesson, we will use these special triangles to help us, but you need to have these triangles available to you, and you need to write them on your page so that your examiner knows you haven't used your calculator. Okay, Clomelo, is that helpful? Can you see those 2 special triangles? Or do you have any questions? Like, let me just ask, I can't resist. If I said to you, what is the value of the cos of 60, but you're not allowed to use your calculator, what would you tell me? What would you tell me about the value of the cos of 60 if this was your only triangle, or the only thing you had to use? So the cos of 60 has to use this triangle. And if you look at this one, this would be O, because that's the 60, that is the H, and that is the A. But the cos of 60 is just A over H, or if you were using the other way of doing it, X over R. And so A in this case is 1 and R is 2. So the cos of 60 is in fact a half as well. Okay, so watch out because cos deals with A over H. All right, everyone, it's time for a little break. We're not going to have a huge long break, but it's important that we do just take a moment to stand up so that our bodies feel like they are just have a chance to refresh so we get the most out of the last 20, 25 minutes. So let's just start with 4 deep breaths. That's 1. Two. That's 3. And 4. And let's just go straight to jumping jacks today, just to get the blood pumping. So we're going to do 20 jumping jacks, and we start in 3, 2, 1. Let's go. Halfway. Ooh, and I can definitely feel that my body has had some blood flow going through it. Okay, give me a thumbs up if you feel a bit refreshed. Give me a thumbs down if it had no impact on you. Okay, so I'm going to shorten the break today because I know there's a lot to get through. And so let's go back and, oh, I can feel my heart rate is still humping. So let's go and do another question like the one we just did. So let's go to this past exam question and let's go and look at number 2. So I want you to try and take on this question. And what you need to do is you need to simplify it without using your calculator, which basically means 2 steps. You need to reduce the angles and then evaluate them using special triangles. See if you can do that. And then while you're working on that, I will take questions. So Tato, you can take a break. You probably can't do jumping jacks, but you can just take a mental break where you just take a minute to look around the room and, maybe you breathe in a little bit, take a sip of water, that sort of thing. That's what I would recommend. But I agree, you can't do jumping jacks. That would be a little bit too much, I guess. Let's see how we would do this. Aha, so Bolcanio has asked, what do we do with cos of 750? So Bolcanio, if you want to think about the nearest horizontal for 750, think about this. One trip around the sun is 360. A second trip around the sun is 720. And then to get up to 750, you're going to end up in quadrant number 1. Now, if you're in quadrant number 1, you know that this thing ends up being positive. Because you're using the horizontal, you stay with cos, and that just breaks down to plus cos 30. So because trig functions are cyclical, they repeat themselves, that's the way you would do that. Now, what about this next one? What quadrant is that going to be in? 360 minus 45 is here. So that would be negative tan 45. This one, that's going to be quadrant 4, but cos isn't positive there, so that's going to be positive cos theta. I'll give you a bit more time for the bottom line and to further, but if you have questions like Bolcanio, just get your questions coming or raise your hand and we can take them on. So the question from Tato is, how is it positive cos theta? Do you mean the one in the numerator up here, Tato? Do you mean that one? Or do you mean the one down here with over here? I'll call it the blue cos or the red cos? Which one do you want me to clarify? The top one. Okay. If you imagine the cos of negative theta, negative angles go in this direction. So what quadrant am I in? I'm in quadrant 4, and cos is always positive in quadrant 4. How far away is it from the nearest horizontal? It's just theta. So we say it's positive cos theta. Whereas if we say 360 minus theta, we're also going to end up in quadrant 4. So 360 would be all the way around, but minus theta means come back this direction. And that's why this one is positive cos theta. And because the top and bottom are the same, we can actually just cancel those two out. So we're now left with trying to simplify, or we can even put the negative in front. So we go negative cos 30 times tan 45 over, what have we got left? Minus sine 60 times sine of theta. Now, who wants to give me the next step after that? Who has some ideas for the next step after that? Ooh, Andila has said, look at these two over here. The cos of 30 and the sine of 60 are actually connected. And if we use, in fact, before I do that, I'm going to say, look, there's a negative over a negative. And what does a negative over a negative give you? It gives you a positive. So I'm almost going to cancel those two out. But I'm going to say the cos of 30 can be written as the cos of 90 minus 60, if I want. And if I write it as 90 minus 60, then I can actually convert that to the sine of 60. And it's positive sine of 60. And then on the bottom here, you have a sine of 60. And then what else do we have left? We've got a tan of 45. And we've got a sine of theta. But the sine of 60, that can be cancelled. So now I'm just left with the tan of 45 over the sine of theta. Positive cos theta is not negative. Yeah, positive cos 30 is in the first quadrant. So even though there was a negative in front, the negative has been cancelled out. The cos of 30 is in quadrant 1. So everything in quadrant 1 is positive. And everything over here, so both of these are positive. Okay, now we have to evaluate something. What is the tan of 45 going to be? So what happened to the negative of the tan? Oh, did I leave something out? Okay, let me go back and have a look. I did. Yes, apologies. So the negative, oh, no. So the negative moved to the front. Sorry. So have a look at this. Can you see there's a negative, a positive, and a positive? If you multiply those together, you end up with a negative in front. Notice how here you have a positive, negative, positive. You end up with a negative. Does that help? Now, we still have to deal with the tan of 45, and we're going to use my special triangle. And the special triangle that I'm going to use is going to be this one. So what is the tan of 45 the same as? Almost, Kapotso, you're almost there. So my final answer for tan 45 is 1, but there's still a sine theta. So the final answer will just be 1 over sine theta. And if you want to see the full working out, I've got it here. So I can even show you so that you can take a screenshot. This is sort of the example working. You can see it there. Is it fine if we skip the reciprocal of cos 30 to sine 60 and went straight to special angles? Yes, Josh, completely fine. Absolutely golden. There's not just one way to do this. And then the other question is, why is tan 45 1? Well, if you think about what tan of 45 is, tan is O over A. So if you look at this, that's the O and that's the A. So that's why I get 1 over 1. Now, there are different ways to do this. It's not the only one way to do this. For example, over here, you can actually go straight to special triangles at this stage. And then the negatives just end up knocking each other out. But at some point, the negatives knock each other out. Okay. Could you please re-explain how the tan of 45 became negative? Okay. All I did over here, okay, let's go back to the very beginning. So if you look at this tan of 360 minus 45, can you see this is the same as the tan of 315? Now, what quadrant is that angle going to be in? So if you think of 360 minus 45, I'm going to be in quadrant 4. Is tan positive or is tan negative? Tan must be negative in this quadrant. That's why there's a negative here. Does that help, Emmanuel? And does that help, Tato? Okay, pleasure. Glad. Thank you for your questions. Okay, now I want to do one more type of question before we close out tonight. We've done some reduction and formula stuff, and that's great. But another common question is something like this. So we're just going to finish with this question today. Okay. Now, in this question, it says if the tan of theta is this, and it's negative, and theta is between this, determine using a diagram the value of the following things. So I want you to draw the diagram that you think you may need to answer these two questions. And if you can't do it, just give me a thumbs down. Give me a thumbs up if you think you can draw the diagram that this information is asking about. And you can be honest, it's fine. We've got 10 minutes left, so we're gonna. Okay, I'm watching the thumbs. I'm seeing more downs than up. Okay, so let's think about this. If an angle is between 180 and 360, it has to be either in this quadrant or that quadrant, because 180 is here, 360 is here. So the choice of quadrants that are involved is going to be one of these two. But they also say that tan is negative. Now, tan is negative in this quadrant and in this quadrant. So what quadrant do you think I'm going to do my drawing in based on the math so far? On the information that I'm looking at here. Okay, so I have to work in quadrant 4. Okay, so that's the good news. So let's do it. And what we do is we actually draw a triangle in quadrant 4. Okay, now, if you look at this information, the tan of theta is minus √3. A cool trick that you can do is you can say minus √3 over 1. And it's still the same thing. Why do you think I wrote this as minus √3 over 1 and didn't leave it like this? Does anybody have an idea why I put the 1 there? Because I know that tan is a ratio of sides. So tan has to be O over A, or it has to be Y over X. Okay, but here's another problem. If I want to put this onto the length of my sides here, do you think Y is going to be negative? Or do you think Y is going to be positive? Okay, so if Y is going to be negative, where does the negative have to go to? The negative, in this case, let's just see it's in the right place. 1. Okay, so in this case, if this is Y and this is X and this is R, the Y is actually going to be minus √3. Okay, and what is the X going to be? It's going to be 1. Okay, now, can you work out what the R is going to be? What is R going to be? What are you going to use to help you find R? So I think we use Pythagoras and we say r squared is equal to 1 squared plus minus root 3 squared. So r squared is equal to 1 plus 3. And so r squared is 4, therefore r must be 2. Okay, now, if I know the value of all of these, what is the value of the sine of theta going to be? What is the value of the sine of theta going to be? So think about what is sine? Sine is over h or y over r. What is that going to give me for this particular situation? Well, we said y is minus root 3 and r is 2. So we get minus root 3 over 2. So all that you have to do in this type of question is draw your drawing and then interpret it. Now, that is the answer for A. What about the answer for B? So I want you to try and figure out for me what is the value of 3 cos theta using the information in the drawing. So cos of theta would just be, let's think about it. So A over H or X over R. Now X would be 1 and R would be 2. So 3 times a half, or 3 over 1 times a half, is just going to be 3 over 2. Because cos is X over R in this particular drawing over here. Does that make sense, everyone? Give me a thumbs up if that makes sense to you.